now this was the question which I gave you yesterday. Any answer?
Ma? Ma?
Yes, Hemant. Any answer for this question? Did you take this question or not? Hello? Hemant, am I audible? Please respond.
Sir, they don't respond, sir.
Fine. What did you say? What is the answer for this question? Total number of revolutions before it stops.
Sir, they don't 600.
3600. Very good. So, how you did it?
Sir, by using equations of motion, we can get that.
Fine. Equations of motion, we can do it. Fan rotating at 360 rpm. So 360 rotations per minute is our velocity. Okay, angular velocity. Rotations per minute, we will convert into rotations per second. Okay, in 1 minute there are 60 seconds, so divide it by 60. So we'll get rotations per second. So it takes 20 seconds to stop. Means in time t equals to 20, its velocity becomes 0. Angular velocity becomes 0. So ultimately what we can calculate by using equations of motion, we can calculate the displacement covered, angular displacement covered. Total angle we will get. Divide the total angle covered by 360 and we will get our answer. Because in one full revolution 360 degree is there. Getting it? Now, next is relation between linear and angular velocity. Linear velocity, see, we know that in the radian measure of angle, that is circular measurement, angle covered is equal to arc divided by radius. Arc covered divided by radius of the circle. So angle is equal to arc upon radius. This we now divide both sides by time. Divide both the sides by time t. What do we get? We will get v equals to r omega, where omega is axial velocity, v is tangential, and radius is horizontal. Means what? All three are mutually perpendicular to each other. So what do we get? V equals to omega cross r. This we will get. Okay. Take it down fast.
Sir, how here v equals to omega bar plus r bar, sir?
See again, omega is what? Axial vector, is it not?
Yes, sir.
Omega is axial vector, this we already know. And r is what? R is radius. So radius we can also take as vector quantity.
Yes, sir.
Okay. which is starting from center and directed towards the periphery. Okay. And tangential velocity ultimately is a velocity, so it is also a vector quantity. And what sentence we wrote? We wrote that angular velocity is axial velocity, and axial component we are getting by two mutually perpendicular components. Radius is perpendicular to the tangential velocity. Getting it? So radius, which is perpendicular to tangential velocity, when we are multiplying both of them, we are getting axial quantity. So we are getting the direction by right hand thumb rule, which is the direction of a cross product. Getting it? Cross product of vectors gives us same direction, mutually perpendicular direction. Getting it?
Sir, copied, sir.
Copy. Now, see this question. A particle is moving with a constant velocity of 5 meter per second towards the x-axis along line y equals to 5. Calculate the angular velocity of particle about origin when it is at point A and point B. Try solving it. Yes, any answer?
Sir, in the V equals to R omega, V is the perpendicular velocity, sir.
Yes.
16/25, sir.
16/25 radians per second. Very good. Excellent. Excellent. Here, one thing we need to remember. Okay, what is that? That is, we always take perpendicular component of the velocity. We will not take the perpendicular component of the radius, but we will take perpendicular component of the velocity. Velocity component which is perpendicular to the radius. A radius means what? Wherever we are standing, whatever is our reference point. Okay. So omega will be equal to perpendicular velocity divided by radius. Always remember that, because sometimes students do what? They apply inverse, means they take perpendicular component of radius itself, which is wrong. Now, radial and tangential accelerations. See, whenever a particle is revolving in circle, it will always have two components. One is tangential component and other is along the radius. Radius means towards the center. Tangential component is what? Rate of change of speed. If the speed of revolution is changing in circle, then what will happen? Then we will have tangential acceleration. Then we will have tangential acceleration. But the acceleration which is towards the center is called centripetal or radial acceleration. Got it? This centripetal or radial acceleration is given by omega square r or v square by r. Here it is tangential acceleration, which is responsible for changing the magnitude of speed, and AR is responsible for changing the direction of particle in circular motion. Taken down till this point?
So since velocity changing in direction and magnitude, we have two accelerations, no, sir.
Yes.
Copy, sir.
Now, these two components are mutually perpendicular. Therefore, the acceleration of the particle will be what? Total acceleration of the particle will be under root of square of both of them. Getting it? This will be the total acceleration of the particle. Okay, this we have seen. Now let us see the proof. For tangential acceleration, we already know acceleration is rate of change of velocity, so dv by dt.
Sir, it should be magnitude of v, I said.
Rate of change of velocity.
So you said that tangential means due to change in the value, no, sir, not direction.
dv by dt, at is due to the change of value. Due to the change of direction, it is centripetal acceleration.
So then at should be dv by dt, d by dt of mod v, no, sir.
d by dt of
Mod v, no,
d by
sir.
dt of see, when we are saying velocity, that is instantaneous velocity. Okay, that is instantaneous. No need to take mod because here it is already revolving. By negative sign, if you mean clockwise or anti-clockwise, then keep the negative sign because ultimately the direction will be in clockwise or anti-clockwise. Got it?
I got it. Got it, sir.
Now, derivation of this angular acceleration. Draw this diagram first of all, carefully.
Sir, drawn.
Drawn? Drawn
Yes, sir,
this
got it.
triangle?
Sir,
Drawn
drawn,
this
sir.
smaller triangle. Fine. Now, see what is happening. Delta R, we already know that delta R will be given by vector law of addition. And what is vector law of addition here? R1 plus delta R will give us R2. Okay. So delta R will be R2 minus R1, that we know already. Similarly, the change in velocity, see the tangential velocity. What is the tangential velocity? Tangential velocity will be V1 and V2, which is perpendicular to the R1 and R2 respectively. So we are drawing this triangle V1 and V2. Change in velocity will be what? Change in velocity will be V2 minus V1. And this V2 minus V1 will be in direction of center. As the direction of acceleration is towards the change in velocity, which is directed towards the center, why is it that both the why is it directed towards the center? It is directed towards the center because both the triangles are similar. Now, thing is, why these triangles are similar? These triangles are similar because angle between them will be same. Angle between R1 vector and R2 vector is delta theta. Similarly, angle between V1 vector and V2 vector will also be delta theta. Why it will be delta theta? Because both are perpendicular to R1 and R2. Both are perpendicular to R1 and R2. Getting it?
So got it.
Now both the triangles are similar, so what we can do? delta R upon R will be equal to delta V by V. Okay. Now take R and V on other side. So delta V equal to V upon R into delta R. Okay. Delta V equal to V upon R into delta R. This V we are taking on this side. Okay. Now divide both of them by delta T. So delta V upon delta T will give us acceleration and delta R by delta T will give us velocity. So what do we get? We will get here acceleration. Here we will get acceleration. Getting it? So ultimately what do we get? V square upon R.
Sir, we are applying the limit to get instantaneous acceleration, sir.
Yes, what did you say? Your voice is not proper.
Sir, we are applying the limit to get instantaneous acceleration, sir.
Instantaneous acceleration, yes. Limit delta T tending to 0. Above we get average acceleration. Okay.
Sir, copy it. Sir, copy it.
So ultimately what we are getting? We know that V equals to R omega. So when we put R omega, we get another formula omega square R. And again R omega is velocity. So we get V into omega or V into d theta by dt. These are the values of centripetal acceleration. Take them down.
Sir, copy it, sir.
Copied. Now take down this note. Since V equals to R omega, then differentiate the equation. What do we get? We get tangential acceleration as R alpha. Alpha is d omega by dt, which is angular acceleration. So this is angular acceleration. Alpha and tangential acceleration is at. So now in circular motion we can have three types of acceleration. Angular acceleration, which is increasing its angular velocity. Tangential acceleration, which is increasing magnitude of its tangential velocity. And centripetal acceleration. Centripetal acceleration, which is directed towards the center.
That is responsible for direction change. So centripetal is the acceleration responsible for direction change. Sir.
Yes.
Sir, copy it, sir. Sir, copy it.
this question now. Particles travels in a circle of radius this much at a speed that uniformly increases. If the speed changes from this much to this much in 2 seconds, find the angular acceleration. Try solving it. I'm just coming in a minute.
So 2.5, sir. So 2.5, sir.
2.5. Very good. Answer is 2.5 radians per second. Here also we are doing nothing, just applying direct formulas. First of all, we need to find tangential acceleration, and then using tangential acceleration, we can find angular acceleration alpha. Okay, next question. Try solving it. You have 3 minutes.
So 2.5 r squared, sir.
2.5. What did you say?
So pi squared, sir.
Fine. Very good. Correct. Next is instantaneous axis of rotation. See, instantaneous axis of rotation is nothing. Whenever a particle or an object is covering any kind of curve, it is taking any kind of curve, then we can consider that curve as a very small part of a large sphere, of a very large circle, and we can apply the concepts of circular motion. Getting it?
So getting, sir.
So this is called, just a minute. Yes, now. So we know that in uh, instantaneous axis of rotation, we are considering it a small part of very large circle. Getting it? So tangential acceleration, we already know it is v square upon, sorry, what is the acceleration? Acceleration is v square by r. R is the radius, perpendicular radius. Okay. R is the radius of imaginary circle of which this small arc is considered to be a part. From here, we can clearly calculate the radius. What will be the radius? V square upon perpendicular component of acceleration. Perpendicular component of acceleration. Again, what we need to do here, particle is moving over the road like a car is going over a speed breaker. Okay, then that speed breaker must have a radius. That speed breaker must have some radius. What is that radius? For that we are using v square upon acceleration, that is perpendicular component of acceleration. Okay, with the help of questions you will be able to understand it clearly. Taken down.
Copy it, sir.
Next is dynamics of circular motion. Dynamics means now force is in the picture. Now if m is the mass of a body, if mass of a body is m, then what? Then mass multiplied by acceleration will give us what? Will give us force. So if m is the mass of body, then we will have tangential force. What is the tangential force? M into dv by dt. Instead of dv by dt, we can write d omega by dt or dr omega by dt. So ultimately what will be the force? mr alpha. Alpha is the angular acceleration and F will be tangential force. Taken down.
Sir, taken down, sir. Sir, copied, sir.
So what will be the force towards the center? Force towards the center will be what? Multiply mass with the acceleration. That will give us what? That will give us centripetal force. mv square by r or mr omega square.
So copied.
Copied.
Yes, sir, copied.
Now, till now we have seen centripetal force. Next is centrifugal force. Now, what is centrifugal force? See, whenever you are sitting in a car and car take left turn, you feel like your body is leaning towards right. Your body leaning towards right. This is what? This is centrifugal. Getting it?
Sir, getting, sir. Sir, inertial force means what, sir?
Inertial force means because of inertia. Like when you are sitting in a bus and suddenly brakes are applied, your body leans in forward direction. We call it because of inertia, the body is leaning in forward direction. That force of inertia is nothing but centrifugal force. Centrifugal force it is called in case of circular motion only.
This force only acts in case of circular motion only, sir.
No. Centrifugal force is the name of inertial force in circular motion. Inertial force will act everywhere whenever there is acceleration. Like car is taking turn, we are leaning in the right direction. Plane is taking off, we are leaning in backward direction. A bus, suddenly brakes are applied in a bus and our body is leaning in forward direction. That is again inertial force. Okay.
Sir, it is an imaginary force, sir.
Yes, it is imaginary force. Why? Because when you are sitting in the car, you are uh, unable to know the cause of the force. Getting it?
Yes, sir.
You cannot know the cause of the force inside the car.
So that's total force we can say.
Yes, this is pseudo force.
Sir, copy.
Copy. Now the question is, find out the tension T1 and T2 as shown in figure. Two blocks are there and they are rotated as shown in figure with 2 radians per second velocity. You need to find out the tension.
So 20 and 16, sir.
20 and 16 what? Newtons?
Sir, Newton, sir.
Very good, very good. How did you do it? Just we need to apply the concept of pseudo force. Pseudo force will be pulling the block in outward direction. That is mv square by r will act in outward direction, and that will create the tension in the string. Okay. Next topic is conical pendulum. First of all, draw this diagram.
Copy it, sir.
Copy. Now, here L is the length of a string, theta is the angle made by the string, and R is the radius of the path. Now, from this diagram, what we are doing? We are just taking a free body diagram of the ball, okay, and from that FBD we are balancing the forces. So what are we getting after balancing the forces? T sine theta equals to mv square by r. This is our first equation, and mg will be equal to t cos theta. Getting it?
Sir, get it.
Take it down fast.
Okay, exactly what is conical pendulum, sir?
Conical pendulum is nothing but just a pendulum tied with a string, and that pendulum, instead of oscillations, what is it doing? It is performing circular motion.
Sir, which is rotating circles, we can say so.
Yes.
So copy it.
Copied. Now second equation and first equation. Divide 1 by 2. Divide equation 1 by equation 2. From here what do we get? We get tan theta equals v square upon rg or omega square r by g.
So copy it.
Copied. Now what will be the tension? Tension is mg cos tension multiplied by cos theta equals to mg. So T equals to mg upon cos theta. Now tan theta we have written and cos theta we have written. So what will be the tension? Tension will be mg upon cos theta or mgl upon under root of L square minus R square. Yes, done.
So done, sir.
Now next is bending of a cyclist. See, you might have seen it whenever a cyclist or a driver of two-wheeler, any two-wheeler, is taking a sharp turn, he always tilt towards the inner part of the circle, inner part of the turn. Why? While taking turn with a constant speed, cyclists bend in inward direction such that the frictional force will balance the centrifugal force. Why? Because when he will tilt, what will happen? Because of this tilt, yes, what will happen because of this tilt? Because of this tilt, the friction will be suffixed. Draw on the diagram.
The friction suffix means what, sir?
Huh?
The friction gets suffixed means what, sir?
Friction gets suffixed means friction will become more sufficient to prevent the sliding. See, if he is not tilted, then what? Then because of the high velocity, pseudo force will be high and it will pull the cycle in outward direction. slipping will start and the cyclist will be injured. Now, to stop that, to prevent that, what he does, he increases the normal reaction. Now what is happening? Now the normal reaction is tilted. Now this normal reaction will have two components, r cos theta and r sin theta. R cos theta will be equal to mg and r sin theta will be equal to mv square by r. Again divide both of them. We get tan theta equals to v square upon rg. So theta is again v square by rg. Thus faster the man will go, more he will have to bend. Getting it?
Sir, getting. Sir, copy it.
Copy. Fine. So our next topic is bending of the roads or banking of the roads. In hilly areas, the roads are banked on turns so as to increase the friction again so that the cars will not slide. Okay. From here we shall see in our next class, that is tomorrow. Or okay, fine, we'll have our class tomorrow. And now after 5 minutes we will have our modern physics class. Okay, is that fine? Can you attend, Hemant? Yes, Hemant, modern physics class, can you attend?